when I saw a car radio with a cassette in the dumpster that had virtually no use on the pinch rollers. As you can see, this now absolutely has use on the pinch rollers. It has played some tapes, but that's because of this thing. I couldn't let it go to waste with the mechanism being that virgin. So, first thing I did was, reverse engineer it. It's a computer-controlled deck. You can see there's two motors. There's the main capstan motor and the mechanism motor, the mech motor. What is really cool is this here. See, eject, that's pause. Rewind, fast forward, reverse play, fast forward play. Isn't that awesome? And you see this little thing here. Now watch as it's moving. And it actually shows you where the mechanism currently is. Like now it's in, sorry about the camera, now it's in reverse. You can see that, it's in reverse. So if I move here, it's in fast forward, reverse play, forward play. Isn't that awesome? So that made it very easy to read out this thing. These three are all ground. And these three encode the state it's in. Unfortunately, it has no rhyme or reason. It's all over the place. So I made this table here where you can see open, open, close. Yeah, offen, Kurzschluss, short circuit, closed. What it encodes, it's like eject encodes a 6, pause is a 3, rewind is a 0, fast forward is a 2, a reverse play is 1, and play is 5. So what I did is I made a lookup table to order those, to put them in the order they appear in. So next thing is I wanted to save as many I/O as possible to implement more features. So one of the things I did is I hooked the buttons up to an ADC input through resistors. This is, if you're designing electronics, this is pretty much a no-no. So many makers of cheap audio equipment, for example, do it like that. They cheap out. I mean, sure, it saves on traces, it saves on it saves on pins, but after a couple of years, these buttons don't make a perfect short circuit anymore if you press them, and then they drift upwards, and then the microcontroller is not gonna read the right values anymore, and it'll just read wrong. So of course the next thing was to put those resistor values in order and have it in, no wait, that's not the right, that's the lookup table I was just talking about with the mechanism that translates the mechanism. This is C code, by the way. Here are the buttons. Here are the buttons, that's the resistor values for the buttons, and they need to appear in the same exact order as the lookup table's drive mechanism. The reason is I need to know, if I push a button, I need to know what direction I need to run that motor in. Do I have to run it do I have to run it into the load position or into the unload position? So yeah, that's kind of important to have that in the same order. Also want to implement a couple more buttons because that's just the basic functions. It's the same exact functions the mechanism has. It's eject, stop, pause, rewind, fast forward, reverse play, play. Which I can just demonstrate. Let's turn that on. I can do it with no cassette in. That of course does nothing. Oh, you missed it. That just loads a tape in. Says there's a tape in, even though there isn't. It doesn't know. There's no sensor actually. I mean, there's a sensor that detects if you have pushed a tape in. But if I decide to not use it, well, I do use it, but you can still use those buttons. The counter is initialized in non-initial. It's not initialized, and it's probably OXF or something. Yeah, I got rewind. Now it's just showing 9999. Got fast forward. Now you can see it counting up fast. It's reverse, and you can see the play is coming on. As play. As you can also see, if it's a reverse play, the counter is not moving because the reel isn't moving at all. I also implemented a little thing that the VTR illuminates whenever the mechanism motor is moving. For some reason, the LP light comes on as well. I do not know why that is. Let's fast forward even more so you can see that this counter is 4-digit, and you can also see a little bit of ghosting. By the way, the S is a real big ghosting because for some reason this thing uses 9 bits. And I'm using the data input bit to the multiplexer. Oh, let's talk about that stuff later. Instead, there's one little feature. If you hold the eject button while powering it on, it goes to record and has a bunch of non-initialized garbage on the screen in the memory. But this lets you measure the resistor value from the ADC. Which means that you now know your resistor values. You know what to put in here. The buttons, come on, focus. Well, almost. Oh, hey, it focuses. What you can put in here, so it's easier to implement new functions. By the way, here is 7 segment. This is just the lookup table for. These are binary outputs as well. So the 8 bits of the microcontroller, 7 of which are hooked up to each of those single segments. If you press several at the same time, you can get funky values. By the way, this is the chip, and this is one of the reasons why I'm stopped developing for this, is, yeah, look at how janky that is. Well, one of the capstan motor control broke off and shorted to the 12 volts. Breaking this IC. It's not dead, it's just write protected now. So this does not have that code, and it also has a stupid bug. Like, I made this thing so if you power it on in any state, first thing it does, if you powered it on, it checks the mechanism and just if the mechanism is in a legal state, it just resumes doing what it was doing. But I forgot to turn on the interrupts, which means that auto reverse would never work. That bug is in here. This also does not have the record function you just saw with the resistor values checked. But since this thing will never be anything but a cassette deck driver, yeah. Okay, let's move over here. This is all on my homepage. That's the 5-volt regulator, and that's a 10-volt regulator for the amp. The amp doesn't need 10 volts. It can run on 5 volts or 12 volts. The most important thing is, though, it must be decoupled from this. Because, as you could just hear, don't know if you can hear that. This thing is currently on. If I didn't have this thing in, the noise would be so loud it will be overpowering your ears. Okay. And by the way, yeah, that's the LCD connector. Won't work because I removed it. I don't need it anymore. Time for a test. Since pretty much everything is gonna hit a content match, let's bless your ears to the wonderful sounds of the Commodore 64. Sound quality is kinda meh. It's about as good as you'd expect a cassette deck to be. Unfortunately, I have a couple of really good cassette decks and know how a cassette deck's supposed to sound. But hey, it works. So let's try reverse. is pretty much just filler material to get the cassette filled up. For example, there's very little bass. Yeah, the circuitry for the head preamp I just got off Google. I just Googled it and yeah, I built it pretty much. Okay, so let's demonstrate auto reverse. Can I stop? Yeah, I can stop it. Yep, auto reversed. And it's not gonna stop now, because now it's checking if that turns, that wheel turns. Now it doesn't check if that wheel turns or not, it only checks if that wheel turns. By the way, this is, see these two things here, this and that? Yeah, they check if the gears turn. So if I stop that, I set it to eject. Hey. Okay, now for the elephant in the room, the VFD. I've set it to its own power supply, which is set to 24 volts. So that's it at 20 volts, which is the limit of what these two chips can output. And I wouldn't have needed this stuff. And it's still plenty bright. Yeah, it's about looks exactly like this in person. Now let's turn it down to 12 volts to see what happens if you just run it off the motor voltage. And it's a tiny bit brighter on camera than it is in person, but it's very close, and you can see it's still usable. It's a bit dim though. And let's run it at 30 volts. That's it at 30 volts. It's so bright the camera can't properly focus it, and you can see a bit of ghosting there. Yeah. So how do I drive it? I only use 5 of the pins from the microcontroller, 2 to drive our good old friend the CD4070. If you see a chasing light animation anywhere, most of the time it's one of these. So what's cool about those is they can reset themselves, so instead of counting to 10, they can, like, you can tell them to only count to 5 or to 6 or to 7, any arbitrary value between 1 and or 2 or 10. 1 doesn't make any sense, but yeah. So see, that's a VFD. If you look, if it would focus, yeah, you can see that there's a mesh that goes here and covers these symbols, and here's another mesh that covers these symbols, and this and that are their own meshes. Let's see if we can show them. Got that camera out of the e-waste container anyway, but you can see the meshes really easy now. You can see all the segments. So of course you can't have them all turned on at the same time, because then all the segments that are lit will be lit on all of those, which means they're probably all gonna be lit. So you need to show one after the other, and you just pulse those. Just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So which chip is really good for that? Yeah. And since that one goes up to 20 volts, I wouldn't have needed all of that. But hey, maybe you got a really, really big VFD, and really big VFDs need more oomph, like 40 volts or 60. Pinball machines with VFDs use 60 volts. So that's how I drive it. It's a microcontroller. Here's a 4017. I use a 7406 open collector driver. It goes through a 10K resistor to a PNP, and yeah. This goes to 24 volts. Here's a 100K pull down, and that just goes to the column strobes. And the same, exactly the same goes to the digits. Exactly the same circuits going to the digits, but here we have a 4094, which is a serial to parallel shift register, which makes it rather easy to control. Oh, yeah, it gives you 8 outputs. It takes away 3 outputs from your microcontroller, but it gives you 8. So you pretty much get 5 extra. So I'm using 7407s because I have more of those, and I don't need them as often because of the good old Commodore 1541 diskette drive. For example, if you unplug the data cable while the disk drive is on, you'll fry these often. So yeah, you like my choice of music? Yeah, my parents hate it too. Okay, ADC init. Well, that's just off the internet. Don't care about that. ADC read, that's off the internet too. Move the mechanism. Where should it go? Let's check where we are. If we are where we should be, then we just return. Stop the timer. Do stuff with turn off the capstan. Set some flags. Set the flags to illuminate in the display stuff. You can see the good old HD 44780 display debug routines. So the good thing is that microchip here, that is easy to control. And that's how you control it. Just set one pin high, one pin low to move it one direction, and reverse the invert it to move it the other way. Then that's a very silly, stupid routine, because if there's a problem with the encoder, which will happen, there will be a problem with that encoder once that mechanism is like 30 years old, and that's what kills all those old VCRs and makes them chew up your tape, is we loop until we are where we want to be. So this routine will run past the end of the stop if it doesn't read the correct value, which it won't when the contacts wear out or get dirty. And then you need to clean it. How should you program it otherwise? Well, I do have an overflow in here, so if a timeout, if it takes too long to move, that's one thing you could do it. Another thing is to check if it reads a legal value and see if you're getting closer to where you want to be. Yeah, turn the timers on for if we're going into play, rewind it, anything that's not stop or pause. Checking, turning on the interrupt for the real switches. Light switches, turn on define the I/O, just mundane stuff. Yeah, I try to save the counter to EEPROM, so if you turn it off, or if you turn it to stop or something, for some reason that actually didn't work. Turn on the timer, set interrupts. Also, it checks if the mechanism is in an illegal state, it just goes to eject. Otherwise, it'll resume doing what it was doing. So, yeah, here's the main loop. The main loop reads the buttons and pretty much does nothing else. And here are our interrupts. We have a lot of interrupts. That's the interrupt for the supply reel and play inside one. All it does is set a flag. Here's the interrupt for the take-up reel inside one. It sets a flag and also increases or decreases the counter depending on what state's in. That's the timer 1 overflow. It checks if the flag is set. If the flag has not been set, then the reel isn't moving, which means we have to stop or reverse or eject or something. And this is strobing the display. This is what's running the display. So, yeah. Depending on what digits it's on, it needs to either interpret flags or do an integer to ASCII to 7 segment. Yeah, that's what I'm doing. Integer to ASCII to 7 segment. Okay, I forgot a few tidbits. One thing is that you should run the filaments on AC. I cheated. I run them off 5 volts through a 16 ohm dropper resistor. And if you want to know which of these pins goes where, well, you can easily see it. You can see which pin goes to pins go to the meshes, and if you wanted to know which pins go to which segments, then you can see that on the back side.